Today's point is center tapped full wave rectifier. This is one type of rectifier which converts AC signal into DC, and to design this rectifier, two PN junction diodes are required. First of all, we will see the circuit diagram of this rectifier. So, here the complete circuit diagram of this rectifier is shown, in which two diodes, diode D1 and D2 are connected. Then here single phase 230 volt AC supply is connected to primary winding of the step down transformer. Here the special type of transformer is required, called center tapped transformer, because in this transformer from center point of the secondary one wire is taken. Therefore, this transformer has three output wires. Then the cathode terminals of two diodes are shorted and load resistance is connected between cathode and center point of the secondary winding. So, when current flows through the load resistance, then output voltage is available, that is load voltage EL. Then here in secondary winding the voltage is induced. In upper half portion the voltage is ES, again in lower half portion it is again ES. The next is the operation of this rectifier. The operation of this rectifier is divided into two parts. So, first is consider the operation in positive half cycle of the input. So, operation in positive half cycle of input. So, consider positive half cycle of the input. So, when input is positive half cycle, voltage induced in secondary such that the point A, this upper point of secondary winding, is positive and point B is negative. So, with these polarities, anode terminal of diode D1 is positive, therefore D1 is forward biased. Anode terminal of diode D2 is negative, therefore D2 is reverse biased. So, diode D1 is on and diode D2 is off. So, here we can replace this diode D2 by open switch, because no current flows through the diode D2, and in positive half cycle of input current flows through the diode D1, then that current flows through the load resistance and finally through the upper half of the secondary winding. So, current completes loop, and because of this current the output voltage is available across the load resistance, means here through load resistance the current flows, called load current. So, in the waveforms we can see three different waveforms of this rectifier. The first is the secondary voltage, that is input. The second waveform is of load current, and third waveform is of load voltage, that is output. So, in positive half cycle of the input, diode D1 is on, therefore load current flows, and this load current depends on the secondary voltage, that is input. So, when secondary voltage increases, load current increases. When secondary voltage decreases, load current decreases. So, we get the load current which is positive. Then the output voltage, that is EL, depends on this load current. So, when this load current increases, this load voltage increases. When load current decreases, this load voltage decreases. So, at output the positive half cycle is produced, means the output voltage is available in positive half cycle of the input. Then after completion of negative half cycle starts. So, operation in negative half cycle of the input, negative half cycle of the input. So, in negative half cycle of input, polarities of these 2 points are reversed because voltage induced in secondary such that this point A is negative and point B is positive. So, here initially consider both diodes. So, here initially consider both diodes, diode D2 and diode D1. So, with these polarities, anode terminal of this diode D1 is negative, therefore, diode D1 is reverse biased. Anode terminal of D2 is positive, therefore, D2 is forward biased. So, in negative half cycle of input, diode D1 is reverse biased. So, we can replace this diode D1 by open switch because no current flows through the diode D1. Then current flows through the diode D2, then that current flows through the load resistance, and finally that current flows through the lower half of the secondary winding. So, here load current flows, therefore, the load voltage is available. Here the important point to note down is the direction of this load current is same in both half cycles, is in positive half cycle and in negative half cycle. The direction of this load current is same. Therefore, even if input is negative half cycle, at output positive half cycle is produced. So, in negative half cycle, when input the secondary voltage increases towards negative, this load current increases. When secondary voltage decreases, then load current decreases. So, here in negative half cycle, diode D2 is on, therefore, load current flows which is positive. So, because of this load current, this load voltage is available. When this load current increases, load voltage increases. When load current decreases, load voltage decreases. So, in this way, in negative half cycle, positive half cycle is produced at the output. Then after completion of this negative half cycle, again positive half cycle starts. Again polarities are reversed, diode D1 is on, load current flows and the load voltage is available. So, at output we get continuous positive half cycles. So, this type of signal is called pulsating DC signal. So, in this way this AC signal is converted into DC by this center tapped full wave rectifier. Then here the advantages of this rectifier are, the first advantage is the efficiency is high. Means here the maximum efficiency of this rectifier is 81.2%. Efficiency is high means the DC output power is more. Second advantage is the ripple factor is low. Here ripple factor value is 0.482. Third advantage is the transformer utilization factor is better. Here TUF is equal to 0.692. Then fourth advantage is the ripple frequency is high, which is 100 Hertz. Then this rectifier has the disadvantages, like the first disadvantage is the center tap transformer is required. Means here the special type of transformer is required called center tap transformer, whose cost is more and size is big. The second disadvantage is the peak inverse voltage is high, that is PIV is equal to 2 Vm, means here the diodes with high peak inverse voltage are required. Third disadvantage is poor voltage regulation, and fourth disadvantage is not suitable for high voltage applications. So, because of such disadvantages, this rectifier is not used in DC power supplies. So, this is all about this center tap full wave rectifier.